Today we're going to look at lesson 10.1. We're actually going to jump around in the book a little bit, and we're going to look at areas of parallelograms and triangles today. So our objective is to find the area of parallelograms and triangles. The first theorem we're going to look at should be a little bit of review. The area of a rectangle, and we've even worked with it several times this year as well. The area of a rectangle is simply the base times the height. So we have a figure drawn in blue, and it's a rectangle, and I've marked the right angles. And what we're going to do is we're just going to label the base and the height. So in a rectangle, one of the sides is the base, the other side is the height, and they are interchangeable. We could have this side over here be the base and this one be the height. But basically, for the area of a rectangle, we're just going to take one of the sides times the other side. So simple as that. Area equals base times height. Now imagine taking that rectangle and kind of making it slanted. So we're taking a rectangle, we're going to turn it into a parallelogram. So let's just say that we took and turned this blue figure into a parallelogram. Let me take out those last little ones I did. So now we have the figure in black. Now all we did was we took the rectangle and we kind of slanted the sides. Did we change its area any? And the answer is no. So the area of the black shaded region is still base times height, and that's what we're going to find for the area of a parallelogram. And that's theorem 10.2. The area of a parallelogram is still base times height. But what's interesting here for a parallelogram is we can make one of the sides the base, but the slanted side, okay, like right here, that's not the height. Okay, that's just one of the sides of a parallelogram. The height is actually going to be the distance between the bases. So if I drew in this height that was perpendicular to one base and perpendicular to the other, this segment right there is the height. Or sometimes we refer to it as the altitude of the parallelogram, but they're interchangeable. So the area of a parallelogram is still the base times the height, except now the height is the distance between the two bases. Let's take a look at an example.
In this problem, you will find the area of a parallelogram. Part A. What is the area of the parallelogram? You are given the height. Remember that the height of a parallelogram is the length of an altitude. Why aren't the sides of the parallelogram considered altitudes? Altitudes must be perpendicular to the bases. Unless the parallelogram is also a rectangle, the sides are not perpendicular to the bases. Choose the side perpendicular to the altitude, labeled 5 inches, to use as the base. Write the formula for the area of a parallelogram. Substitute 5 for B and 4 for H. Now simplify. The area of the parallelogram is 20 square inches. Part B. What is the area of the parallelogram? You are given the height. Choose the side perpendicular to the altitude, labeled 2 centimeters, to use as the base. Write the formula for the area of a parallelogram. Substitute 2 for B and 3 5/10 for H. Now simplify. The area of the parallelogram is 7 square centimeters.
Okay, and I want to point out in both of those problems, in A and B, When we labeled the area, we labeled as square units, in this case square centimeters. And that's because we're taking and multiplying the units as well. So in this problem, we took 2 centimeters times 3.5 centimeters, yielding 7, and we had centimeters. We had 2 of them, so it was square centimeters, or centimeters squared. Area is always going to be labeled in square units. So remember that as you're working your problems, that whenever we have an area problem, it should be labeled as square units. Okay, let's look at the last theorem. That's theorem 10.3, the area of a triangle. And some of us probably already know this area formula, but let's take a look at where it comes. In that we know that the area of this rectangle that's given, if this was B and this was H, then the area is equal to base times height. But if we take this rectangle and draw in a diagonal, we have now split it into 1, 2 congruent triangles. So the area of just this triangle right here is going to be half of the area of the original rectangle. And that's where we get our area of a triangle formula, that the area of a triangle is 1/2 base times height. Some people ask where the 1/2 comes in. Well, it comes in because the area of a triangle is 1/2 the area of a rectangle. And we can always take a rectangle and cut it into 2 triangles. So let's take a look at a problem dealing with the area of a triangle.
In this problem, you will find the area of a triangle. You want to make a triangular sail like the one at the right. How many square feet of material do you need? Step 1. Convert the dimensions of the sail to inches. Why do you need to convert the base and the height into inches? You must convert them both because you can only multiply measurements with like units.
And that's one of the things you're going to face when you do your homework today, is to make sure that when you're finding the area of a figure, that both dimensions you're using are in the same measurements.
First, convert the height. Use a conversion factor. So 12 feet, 2 inches is 146 inches. Now convert the base. So 13 feet, 4 inches is 160 inches. Step 2. Find the area of the triangle. Write the formula for the area of a triangle. Substitute 160 for B and 146 for H. Now simplify. So the area of the triangle is 11,680 square inches.
But now here's where we sometimes forget that it asks us to convert it into square feet. So we have the 11,680 square inches. We need to convert that into square feet. And people mistakenly divide by 12 at this point. The problem here is that we have square inches into square feet. So we need to divide by 12 twice. And you're going to see that here as we finish the problem.
Step 3. Convert 11,680 square inches to square feet. Be sure to use the conversion factor twice this time, since you're converting inches squared. The area is 81 1/9 square feet. So you need 81 1/9 square feet of material.
Okay, the last problem we're going to look at is if we're putting shapes together. So in this problem, we want to find the area of the figure at the right. And we basically, it looks kind of like a house, I would say, in which the base, this part of the house is a square, and This top of the house is a triangle. So we didn't have a area formula for a square, but it's still base times height. So let's take a look at that on a little different thing here. I've tried to draw the same thing on the drawing canvas, and of course it's not going to look exactly right. We'll do the best we can. So first of all, in order to do this, we're going to break it into two parts. We're going to find the area of the square, and we're going to add that to the area of the triangles. We do two separate problems. So let's do the area of the square first. So the area of the square is going to be base times height because it's also a rectangle. And since it's a square, both the base and the height are the same thing. So they're both 6. So the area of the square is 6 times 6, or 36. And it looks like we're in inches, so it's going to be 36 square inches. And we're going to add to that the area of the triangle, which is 1/2 times base times height. Now we're looking at just the triangle here now. Now it didn't give us what the base is, but because it's part of the square, we know that that area is going to be, or that base is going to be 6. Now what is the height of the triangle? The height of the triangle is the altitude, or in this problem it's 8. So we're going to add to that 1/2 times 6 times 8. Well, half of 6 is 3. 3 times 8 is 24. So the area of the triangle is 24 square inches. So the area of the entire figure is the area of the square plus the area of the triangle, and 36 and 24 would give us 60 square inches. Okay, so that's lesson 10.1. Don't stop the video yet. I've got something I want you to do at the end of the video to get your credit for actually watching it. But lesson 10.1, our objective again was to find the area of parallelograms and triangles, and we expanded that, and we did, the last problem we did was an irregular figure, which we put two of them together. So in order to get your credit for watching the video, I want you to do these three problems. Number 1, I want you to find the area of the blue parallelogram. Number 2, I want you to find the area of the blue triangle. And number 3, although it doesn't look perfect, I was trying to format it in Word, I want you to find the area of the irregular shape, which looks like it's a rectangle put together with a triangle. When you work these three problems, I want you to email me the answers at the email address there. That's my school email address. So make sure you email it to this address right here, and that's how you'll get your credit for watching the video. Good luck.